Hello, welcome to the video where we discuss International A-Level Mechanics 1, October 2017. So it's a problem number 6. An athlete goes for a run along a straight horizontal road, starting from rest. Okay, it's important. So important pieces of information must be underlined. She accelerates at 0.6 meters per second up to a speed of v meters per second. She then maintains this constant speed of v meters per second before finally decelerating at 0.2 meters per second squared back to rest. She covers a total distance of 1,500 meters in 270 seconds. Okay, the first question is to sketch a speed time graph to represent the athlete's run. Okay, let's draw two axes. So the horizontal axis is time in seconds. The vertical is speed in meters per second. So she started from rest, so the initial point is here at the origin. Then we accelerated 0.6. Its rate, it's on the speed time graph. This is the slope of the graph. So let it be like this, 0.6. So until she reached v meters per second, then she maintained that speed for some period of time and then decelerates at a smaller rate of 0.2. It mustn't be as steep as the first segment where she accelerated. So this here the slope is minus 0.2. Here the slope is 0.6. So it's 3 times as steep as this line, as this segment. So it takes 270 seconds, and the area under this curve, the area of this trapezium, is 1,500 meters. Okay, so we don't know these values of time when she started to maintain the speed of v, and we don't know the moment of time when she started to decelerate, but it's okay. B. So it was part A. Part B. Part B showed that she accelerated for 5v over 3 seconds. So, okay, we can consider this part when she accelerated. So the u, initial speed, is 0. The final speed v is v meters per second. Time is unknown, but acceleration is known. Acceleration is 0.6 meters per second squared. So we can use a Suvat, one of the Suvat formulas. It sounds like V equals U plus A times T. So we fill in the formula. So V is capital V equals U, which is 0, plus 0.6 times time. So we can easily isolate the value of t. So 0.6 is 3 over 5 if represented as a simple fraction. And then when it goes to the other side, it must be flipped. So it's 5 over 3v. Okay, that's exactly they wanted us to show. C part of the question, show that v squared minus kv plus 450 is equal to 0, where k is a constant to be found. Okay, so I know from the part B, so this point of time is 5 over 3v. So can I find the period of time it took her to decelerate and stop? So we can consider this part of her motion. Okay, we can denote this is O, this is A, this is B, this is C. So first we considered OA part of her motion. Now I'm interested in BC part of her motion. So let's clearly write down all the parameters of her motion. U, initial speed. She entered this period of motion with the initial speed of v. The final speed v is 0 because she stopped at the end. And what else? Acceleration is minus 0.2 meters per second squared. So negative sign is crucial because it's deceleration. She stopped eventually. And the time is unknown. Time is unknown. So we use the same formula from Suvat. V equals U plus AT. It follows that V is 0. U is capital V minus 0.5. Okay, let's write it as a simple fraction, 1/5 times time. It follows that time is equal to 5V, but it's time during the BC. That was time during OA. Okay, so this is 5V time, and it's better to write this way, 5/3V, like this. So I want to fill this part as well because I know that the total time of motion is 270 seconds. So if I subtract 5V/3 and then I subtract 5V from the total time, it will be time of the period AB from A to B. So now I use geometrical principles because I know the distance traveled is 1,500 meters, which represents the total area under the speed time graph. That is this area, so area of the trapezium. So I split the trapezium into three parts. Yeah, here they are, three parts, and then sum up their corresponding areas. So area of the first part, so let's put Roman digits, 1, 2, 3. So area of the first part, distance I, plus distance 2, plus distance 3, it's equal to, okay, the first area is the area of the right angled triangle, a famous formula, half times 5/3V. It's the horizontal leg times V. It's vertical leg of the right angled triangle. So we continue, plus it's a rectangle with a height of V, but the length of 270 minus, let's write it 25V/3. Am I right? Yeah, I multiplied by 3. Yeah, minus 5. Oh my God, it's minus 20. Minus 20V/3 times the height of the rectangle V. We continue by adding the area of the third region, half. The horizontal leg is 5V, the vertical leg is V again. So the result is 1,500 meters. That's it. That's it. So now we start the long process of simplification. Okay, this is 5V²/6 plus, open the brackets, 270V minus 20V²/3 and plus 5V²/5. Oh no, over 2. Sorry, is equal to 1,500. I want to get rid of the denominator just by doing one step. I multiply by 6. So it's 5V² plus, I use my calculator. Yep, 1620V minus 40V² plus 15V² is equal to 9,000. So let's combine like terms. So V², it's better to collect all the terms on the right hand side. So if I deal with V² terms only, it must be 20V², right? 20V², and then minus 1620V, and then plus 9,000 is equal to 0. So I can easily divide everything by 20. So v squared minus 81v plus 450 is equal to 0. Look, by comparison with this equation, so I deduce k is equal to 81. 81. Okay, where k is a constant to be found, okay, it's done. Find the value of v justifying your answer. Okay, this is the quadratic equation, so it must be two roots. Be ready to understand what root is extraneous root, that is the root I don't need, and which root works. So I use my calculator, 1 minus 81 and 450. So V1 is 75 meters per second, and V2 is 6 meters per second. Okay, they're both positive numbers. If it were a negative number, I would get rid of it right away, but they're both positive. So I have to put some more effort to understand which of the roots must be taken. So let's take a look at this point. This point. So this t of AB period. It's time she maintains the constant speed of v. So if I put here, here, so it's a more simplified version of this time tab. So if I put 75 in this expression, 270 minus 20 over 3 times 75, it would be a negative number. TAB then is minus 230. So which is less than 0? Impossible. Impossible. So I get rid of this root. So V is equal to 6 meters per second. So this is my justification. This is an explanation why 75 doesn't work, because from the first sight it looks okay. So that's it. Very interesting problem, and it's of course typical on M1 exam. So everything depends not only your good knowledge of Suvat, but also depends on your knowledge of geometry. So I hope it was useful for you. See you next time. Bye bye.